Good evening to all. Today I have taken a new topic which is about hydrodynamic bearing. This bearing is used for all the turbo machinery. So let's discuss about hydrodynamic bearing. If you look at this picture, uh, this is a bearing which is taking care of load of the shaft or rotor. And there are two types of bearing. It's combination of two types of bearing. One bearing is called bearing as radial as well as thrust, similarly which is installed at one end, and we have another bearing same configuration, that is radial as well as thrust, which is installed on another side. But if you look at another configuration where one side it has only radial bearing, and another side you will see that it has radial as well as thrust. So both direction thrust is taken care by one bearing which is installed at another end, and this side it takes only the radial load. So what is then bearing? Bearing simple definition is to take the loads. Loads can be a static load of shaft, a static load of attachment which is connected to shaft like impeller, or all the auxiliaries which is contributing the load. But this is one type of load. If the shaft is driven by gear drive, then the load which is coming from gear drive or mesh is also taken care. And sometimes the load due to the bending moment, that all three types of load need to be considered for design of the bearing. Of course, this is one all I have just now explained use only for radial type of load. But we have also thrust load, which is because of the process gas which is acting on the rotor and cause the axial thrust. So bearing can take or designs in a such a way that it should also take radial load as well as axial load. So radial bearing is designed to take care of radial load, and axial bearing is designed to take care of axial load. Now the operation philosophy and how it is designed, it has been shown in a very simple way. If you see the man which is carrying the load on his head, but if you look at carefully, the pad or some soft material is placed between the load and head to protect, to protect the head from the load. Same thing, this is a bearing shell, and this is shaft load. So shaft load cannot be taken directly on the bearing shell. So you need a pad. That pad is called bearing babbitt material, which is of shaft material. So load is transferred not on the shell directly, but through the pad or what is called babbitt material, which is fixed to the inside of the cell to take care of the radial, or in case of thrust, on the thrust facets. This man is taking load and moving, you can see. But if you look at carefully, there is no relative motion between the load and pad. But in case of shaft and bearing, it is designed or it is used to take the load when shaft is moving. That means there is a relative motion between the shaft and the bearing, Whereas a man, even though it is walking, taking the load on his head, there is no relative motion. So this change, even though this man is carrying the load, similarly the bearing is also taking the load, but there is a change. What change? Change is relative motion, because shaft is revolving, shaft is rotating, bearing is stationary, so there will be some relative motion. So if there is a relative motion, there will be friction, heat is generated, so babbitt will damage. To take care of the babbitt, we need oil between the load, that means between the shaft and between the between the shaft part, that is called babbitt lining, on the shell. So the load, when shaft is rotating, the load or relative motion or heat is taken away by the oil. So this is only difference between the man carrying the load and the load is taken care by the bearing. So oil is only extra material which is added because there is relative motion. Otherwise, the whole concept is the same. Man carrying the load is similar like shaft. The load is taken care by the bearing. Now hydrodynamic pressure. If you look at this, this is bearing shell, oil is there. The shaft is rotating clockwise. So in clockwise direction, the gap between the shaft and what is called bearing has reduced, and this creates hydrodynamic pressure profile. You can see it is keep on increasing, becomes maximum at this point and then slightly goes down or reduces. So hydrodynamic pressure is created approximately, if you look at this, 45 degree from the vertical, and this is the maximum pressure. So you can see the maximum temperature rise occurs at this point. So hydrodynamic pressure depends on direction of rotation of shaft. So to have hydrodynamic pressure, what are the essential, what is requirement? One is oil, of course pressurized oil. Then there must be relative motion between the shaft and the bearing, and the most important part is a converging area. If you see the area is larger, keep on changing, keep on decreasing to this point. So three parameters are required to generate hydrodynamic pressure. In fact, this pressure takes care of the load. Of course, there is a bearing shell, then bearing babbitt, and there is oil. In fact, heat or load is taken care by the oil and then passed to the babbitt material and finally, the shell. So hydrodynamic, that is why it is called hydrodynamic bearing, because hydrodynamic profile of pressure is generated because of converging area depending on the direction of rotation of the shaft and because of the oil. That is called, it is called hydrodynamic bearing. In industries, all the turbo machinery are commonly used, you can say the bearing. Bearing can be sleeve journal bearing and tilting pad journal. So in journal bearing type, which takes the radial load, can be sleeve journal bearing and can be tilting pad journal bearing. In case of combination of journal and thrust bearing, we have journal bearing, sleeve journal bearing and thrust taper pad bearing. Then we have this combination, tilting pad journal bearing and thrust tapered pad bearing, and then this combination, tilting pad journal bearing and thrust tilting pad bearing. So we have, in case of combination, that means journal and thrust, we have three categories. And broadly we have Slip journal bearing, in journal category we have two, slip journal bearing and tilting pad journal bearing. This is a slip journal, but exactly this is not pure slip because thrust pad is shown. I don't have photograph. But if you don't consider this faces, it is slip journal bearing. You can say slip journal bearing. But don't. This is thrust faces, so it is not exactly the slip journal bearing, but it is slip journal bearing with thrust faces. Cylindrical bore, and it is a bi-direction. All slip bearings are bi-directional. It can be rotated like this. In fact, bearing is not rotating, shaft is rotating. So shaft can be rotated like this, clockwise and anti-clockwise and anti-clockwise. Both are acceptable. And it has two groups. This is groups or four groups for oil supply. Because oil is coming at center and then moving like this on this channel area. 1, 2 or it sometimes 4. And slip journal bearing is suitable for low speed application. So like bull gear application or maybe where the speed of shaft is low. Now the slip journal bearing pressure profile, you can see it is a anti-clockwise. Sorry, this is anti-clockwise. This is clockwise. If the shaft is rotating like this pressure profile is something like this. Area is converging here. Similarly, if it is rotating on counterclockwise, you can see area is converging. So in slip journal bearing, it is a bi-directional bearing. It is suitable for both directions. Now tilting pad journal bearing, you can see these are the pads which is tilting. So there are two configurations. You can see load, that means shaft is between two pads. This is called load on the pads, and you can see this is load on the pad. Sorry, this is a load between the pads and this is load on the pad because load is directly on one pad. Here load is between two pads. So there are two configurations, and this bearing is suitable for high speed application. You can see two pieces of bearing. This is complete. Now pressure profile for tilting pad bearing, you can see this is a loads on between the bearings and loads on the pad. So typically pads can be 3 to 6. If you look at the pressure profile area, if it is a shaft is rotating like this, area is decreasing here, area is decreasing here. Similarly, between the on the pads, the load on the pads, area is decreasing here, area is decreasing here, and area is decreasing. The shaft is rotating like this. If you rotate another direction, the area will be converging area will be changed. Tilting pad journal bearing pivot on the tilting pad. You can see a pivot is at center. So this is suitable for both direction because moment shaft load comes here, it tilts upward, so area decreases here. If you rotate like this, load first come this and area decreases here. So central pivot is bidirectional, but if it is offset, then it is a unidirectional. Like, let's say if the pivot is this direction, then if load is coming or that is shaft load is coming here, it tilts upward, so area decreases here. So larger area direction, please note that it cannot be like this, because if the load comes here but pivot is also closer to this, so whole load will be taken care by this, so this pad will not tilt, and so it cannot be in this direction. So larger offset is the direction of the tilting pad. Very important information. And Babbitt, you can see all Babbitt are of typically 3 millimeter, and so direction is very important. Always larger area is the direction of rotation and cannot be this direction. But central, it can be both direction. Now, sleeve journal bearing, sleeve journal and thrust tapered bearing. This is a taper bearing. If you look at very closely, there is a number of pad you can see, maybe sometimes 6, sometimes 8, and pads have slope. If you look at carefully, it has slope like this. The pad is rising like this. So it can be one direction, it can be both directions, like if it is clockwise. So if you see from this to this, it is increasing. So direction will be in the increasing area, that is clockwise you can say, anti-clockwise. So it is increasing from this to this. So it is called anti-clockwise. And if it is bi-directional, so from this increasing up to center, and from this it is increasing up to center like this. So thrust pad can be unidirection, can be clockwise direction, can be counterclockwise direction, or it can be bidirectional also. So now the sleeve journal and thrust tapered bearing, what could be the direction? As sleeve journal bearing is bidirectional, we know. So direction of bearing depends on direction of the thrust pad. If the direction of thrust pad is clockwise, then direction of bearing is clockwise. If the direction of thrust pad is a counterclockwise, then certainly direction of bearing is a counterclockwise. If the direction of thrust pad is a bidirectional, then direction of bearing is also bidirectional, because sleeve bearing is always bidirectional. Now tilting pad journal bearing and thrust taper pad bearing. So now what will be the feature? Direction of rotation of thrust bearing depends on pivot, because if it is central, it can be bidirectional. If it is offset, then it is the unidirectional. And taper thrust bearing can be also clockwise, can be counterclockwise, and can be bidirectional. So that means the direction of bearing, that means journal bearing and thrust taper bearing, depends on combination of these two directions. Correct? Okay. So if you look at this, if the journal bearing is a directional, bidirectional like this, and thrust pad bearing is a bidirectional like this. So if this and these two combination, then bearing is a bidirectional. If the journal bearing is bidirectional and thrust pad bearing is unidirectional like this, if it is a clockwise direction, then the bearing will be clockwise. If this combination, this is bidirectional and this is again counterclockwise for the thrust pad, then bearing will be counterclockwise direction. The thrust pad is unidirectional and journal bearing is unidirectional and journal tilting pad is unidirectional and thrust pad is bidirectional, then direction of bearing will be direction of tilting journal pad like this, clockwise. If combination is this is a unidirectional, then thrust pad should be also like this, clockwise direction like this. It cannot be counterclockwise. This direction should match to this direction. It cannot be opposite direction. Like so, this is possible, but this and this is not possible. So it is very important for the direction of the bearing. It depends on what is direction of the tilting journal bearing and then what is direction of thrust taper pad bearing. Now tilting pad journal and thrust tilting pad bearing. This is thrust portion. It is again 6 to 8 tilting pads and central pivot like this. It can be bidirectional. If it is offset, then it is again same. If the larger area is the direction of rotation, because if shaft or load comes here, tilts and area becomes converging at this point. So direction should be this, but since offset is closer to this side, so moment the load comes here now, since the pivot is very close, it will not allow to make the converging area at this end, and that is why it cannot be this direction. It has to be only this direction with this configuration. So always larger offset angle is the direction of rotation. Now let's see the direction of rotation of such bearing where tilting pad tilting pad journal and tilting pad thrust. So as you know, the direction of tilting pad, so journal and direction of thrust, both direction needs to be considered for direction of bearing. So if the bearing is a journal bearing is a bidirectional and thrust face is also bidirectional like this, these two combination, then bearing is a bidirectional. If journal bearing is a bidirectional like this and thrust face is unidirectional like this, then bearing will be unidirectional, and direction depends on direction of thrust faces. Similarly, if the journal bearing is a unidirectional and thrust face is bidirectional like this, then the direction of bearing will be depends on the direction of journal tilting pad. If the bearing is a unidirectional and tilting pad thrust is also unidirectional, then like this it is not possible. If it is rotating like this, then you cannot use this combination. Actually this pivot should be closer to this, then direction will be like this. So always you have to see the direction of journal bearing and direction of thrust pad bearing both should match if both are unidirectional. Now we understood the importance of bearing, hydrodynamic bearing. Now how to protect these bearings? So broadly there are other parameters are also for protection of bearing, but we have considered only the three major parameters. One is oil pressure, another is temperature, and third is radial vibration, axial vibration, and bearing temperature. Oil pressure indicates the flow, because once machine is bearing is designed, then if you supply oil with certain pressure, it gives you flow depending upon the area or oil passes and differential pressure. So oil pressure is nothing but it supplies certain amount of oil which take care of the heat generated between or generated due to rotation of the shaft, or between, you can say, shaft and the bearing babbitt. Another parameter is temperature. So sufficient oil should be maintained. That means oil pressure should be maintained. If it is not maintained, then machine has to be tripped or machine needs to be stopped. Similarly, oil pressure, then oil temperature. Oil temperature indicates the viscosity of the oil. Typically oil supply we do is normally 42 degree, 45 degree, and so oil temperature should not be lower. If it is lower, then viscosity becomes very high, and if viscosity becomes very high, then temperature will be rises. Of course it helps in vibration reduction, but temperature will increases, bearing temperature becomes. On the contrary, if you supply hot oil to the bearing, then of course bearing temperature will be high and viscosity will decreases, so vibration will be high because of less viscous this thing. So required temperature is very important for protection of the bearing. Then radial vibration and axial vibration, because we also need to protect the bearing from excessive vibration on the radial side as well as excessive vibration on the axial side. In case of radial, typically 70% of diametrical clearances is considered as alarm, and 90% clearance is considered as a trip. That means if shaft and babbitt comes closer because of process load, closer to 70% of the diametrical clearance, it considered as alarm, and if 90%, it is considered as a trip. But it is one part. Sometimes some manufacturer also does a speed-based protection of the bearing, where EPI formula, which is the square root of 12,000 divided by n is RPM speed. This will give the mils. So if you multiply this, it will give the micron. So this number is a what is called general value or a standard value of vibration. So alarm is considered 1.8 times of this, and trip is considered 2.8 times of this. So some manufacturer what does, they consider both. In case of alarm, they will consider 1.8 times into the API formula, and 70% of radial bearing clearances, and then they consider which one is a smaller, and they consider as alarm. Similarly, 2.8 times of the API formula, and 90% of bearing clearances, they consider take the minimum and then go for the trade. This is one aspect for the radial vibration protection of the machine bearing. We have also axial vibration. Let's say rotor end play is 300 micron. So if you take one side, it will move half. That means 150 micron. Another side also 150 micron. So normally rotor on active side, let's say one side, it is touching, not touching because there is oil film, but you can consider it is very close to the bit, and that means we are giving some manufacturer gives some tolerance or some value for wear out of the babbitt, and it is sometimes 4 mils for alarm, 6 mils as a trip. Some manufacturer also gives 5 mils as a alarm, 10 mils as a trip. In case of tilting thrust pad, the value also given more, like alarm, for alarm it is 10 mils, and for trip it is 15 mils. Just to convert mils to micron, you need to just multiply 25.4, it will become micron. So these are the protection for radial side and axial side, and if during operation, if this value crosses the number for alarm and trip, then machine should trip to protect the bearing. The last one is the bearing temperature. Bearing temperature is also very important, and it also depends on manufacturer to manufacturer. Some manufacturer gives 88 degrees Celsius and as a alarm, 93 degrees Celsius as a trip. Some manufacturer gives 107 degree as a alarm, 112 is a trip. Some manufacturer gives 115 degree as a alarm and 125 degrees as a trip. So it depends on manufacturers and type of construction of the bearing, but it is very important to know, if the temperature becomes very high, the babbitt material gets softened, and there is a chance that babbitt can damage, bearing babbitt can damage, and that is why you should have bearing temperature protections. So with this, actually I have just considered only three parameters for protection of the this thing, bearing. For the oil supply pressure, I did not mention. For the, if pressure goes down, then there will be alarm, there will be trip. That means the flow is lesser and heat is not taken care by the flow by the oil because of less flow. So these are the protections. So I'm sure now you will really enjoy the session for hydrodynamic bearings, where you have seen how hydrodynamic pressure is generated because of rotation of the shaft, And there are two types of bearing. One is sleeve bearing, another is that means journal bearing, another is thrust pad bearing. In case of journal bearing, you have sleeve type bearing and tilting pad bearing. In case of thrust pad bearing, we have a fixed tapered land bearing, and we have also tilting pad bearing. And sometimes there is a combination of journal bearing and the thrust bearing. And also it is very important to know direction of the bearing, because it is combination of journal bearing direction as well as thrust face direction. So I'm sure you have enjoyed this. Thank you, and see you in next video. Thank you. Bye bye.